here 4 bits difference, no? For that case, the least significant bits of the 4 bits will be lost. So then what is the information we are having? So 1, 2 into here 4 will be added means automatically the incrementing the power means 10 cube. Okay, so in that LSB bits will be lost. So then we are getting the power as 10 power 3. So now take the first number AC, that is nothing but 0. What is the first number? 5, 3, 7, 2, 5, 1 into 10 cube. So now add these two numbers. So now we are having the checking these two exponents whether it is equal or not. So these two exponents will be equal. So now what we will do? So after alignment of the mantises, then we are performing the addition or subtraction operation. So here 10 cube common, you can performing the addition operation. So 2 plus 1 is 3, 5 plus 1 is 6, 2, 7, 3, 5 and 0 point. Okay, this is our result we are getting in second approach. Okay, so which is the first approach here? If we use the first approach, that means if you perform the shift left operation on this higher exponent, okay, shift left operation on performing the higher exponent, so automatically here what is happening means MSB bit will be lost. This first 4 bits of the MSB bits will be lost. That means there is a huge loss of information we are having, right? So that means this 0.537251 will be modified into what happened? 0.510000. So that means here this number is very less as compared to this number, right? So automatically we can say that huge loss of information we are observing, right? So that means here we are losing the MSB bits of 4 bits. That is first approach. So whereas if we use second approach, then what is happening here? We are losing the least significant bits of the 4 bits. But here we are not losing that information. We are keeping that information as it is. Just observe here. The first information will be started 0.123, right? So here this 3 will be lost, but 1, 2 as it is we are getting. That means we are not losing the actual information. Okay, so the started number will be 1, 2 only, right? So that means we are keeping that information as it is. So here we can say that the second approach is the preferable approach. That means we have to take the mantissa with least exponent. Okay, we have to take the mantissa with least exponent and perform the shift right operation and incrementing the exponent values. Likewise, we can arrange the mantises. So which one is the preferable means second approach is the preferable because it cannot lost the information. Okay. Okay, so now after aligning the mantises, what is the next step? So once the mantises are aligned, then we have to perform the addition and subtraction operations, right? That means addition of the mantises or subtraction of the mantises will be possible. So for that case, we have to go with this third rule, that is nothing but addition, add or subtract the mantises. Okay. Third step is add or subtract mantises. Okay, so let us take one example. Here I already explained addition procedure and now we'll see the another example. Okay, so let us take some first register contains one number, that is nothing but 0.542 into 10 cube. Okay, and like that BR consists, that means second number I can consider as 0.621 into 10 cube. Okay, so here both the mantises are already aligned, right? So like this. So already mantises are aligned. So then we'll go with the addition operation. So first we'll see the addition operation here. So 10 cube as it is. So 2 plus 1 3, 4 plus 2 6, 5 plus 1, 5 plus 6 I will get the 11. So 1.163 into 10 cube we are getting, right? So that means here both are zeros. Okay, in the first number will be consist of the 0 and the second number will be consist of the 0. That means both are zeros, but the result is 1, right? Here the point is after performing a addition operation, there is a possibility that we may get overflow. Okay, remember this point. Likewise, if you are taking the two numbers as zeros, started with zeros, but you may get the result as 1. So then you may get the one possibility, that is overflow. So this one is nothing but here, that is our overflow bit. Okay, but the register can't store this 1 in that. Okay, overflow bit cannot store in this register. The register will be stored in zeros only. It cannot store the 1. So how we can overcome this problem? How we can overcome this overflow problem means, in order to overcome this overflow, we have to perform the shift right operation. Okay, in order to overcome this overflow problem, we can perform the shift right operation. Okay, so perform the shift right operation means, already we know that what is shift right operation. 0 will be added to the leftmost position. Okay, and all the bits are shifted one position to the right side. Okay, that is the shift right. We are adding zeros on the left side, but we have to move each bit onto the right side. Okay, remember that point. What is shift right operation means, zeros will be added to the left side bit. Here zeros will be added and each bit will be moved to the right side, like this. For example, 101 we are having this information, we are having for this number, we have to apply the shift right operation. So what will happen means, in that the first bit, not this one, so the first bit will be, we are adding zeros, and each bit, the next bit will be shifted to the one position to the right. Automatically, what about the least significant bit? It will be lost. We are getting the 4 bits now, so automatically the least significant bit will be lost here. Okay, so like that here also, this is our number now, 1.163 into 10 cube. So for this I can apply the shift right operation. What happened means, 0 will be added to the left side. Okay, and each bit will be shifted to the one position to right. So what about this 3? 3 will be lost. 0.116 we are getting. Okay, so and what about this radix value and exponent value means, here we have to increment the exponent value. Shift right operation means compulsory we have to increment the exponent, because here 0 will be added now. So that's why shift right operation with exponent will be increased. Increment exponent. Okay, for that case, so how many bits will be shifted here? Only one bit will be shifted. So then automatically we can add one bit. So 10 power 4 we are getting. Okay, so here how many positions are shifted, you have to check it. Okay, so we are shifted only one position, so then we have to add 1 to the exponents, then we'll get 0.116 into 10 power 4. So now this overflow bit 1 has converted to the 0. So now observe this result, there is no overflow here. So that means, after performing the addition operation, so we may get any overflow. So then automatically you can do one thing, that is shift right operation with incremented exponent. You have to check it whether the overflow bit is there or not. If overflow is present, then we'll go with the shift right operation with incrementing the exponent value. This is the addition procedure. If the subtraction operation is performed, what happened? Okay, so let's see the subtraction also. This is the addition procedure. Okay, only two chances will be there, either 0 will come or maybe 1 will come. So if 0 will come, there is no problem, directly you can take it that answer like this. Okay, if any 1 will be, that means our mantissa will be started with 1, so automatically that case is overflow case. To overcome this overflow, you can go with this operation. Okay, so now whereas performing this subtraction, what happened? So here also I can consider the two numbers. The first number I can consider as 542 into 10 cube, and the second number I can consider as 5 3 1 into 10 cube. Okay, so let us assume two numbers. First number will be 0.542 into 10 cube and the second number will be 531 into 10 cube. Okay, so in between these two numbers we are performing the subtraction. So here already aligned the as mantises. Then we will go with the directly subtraction. So 2 minus 1 is 1, 4 minus 3 is 1 and 5 minus 1 is 0 and 0. We are getting the result is this one, right? So here what happened? We are taking that mantissa will be started with 5. For the first number is 5 and the second number of the mantissa bit of MSB bit is 5 only. This will be MSB is as 5 and this will be MSB as something value we are having, right? But not 0. But here we are observing the result of the MSB bit. The result of subtraction of the MSB bit contains the 0. So then if the MSB of mantissa is 0, we can say that it is a underflow problem. Okay, so we may have one possibility, that is underflow problem. So how we can overcome this underflow? We have to perform the, to overcome this underflow, we have to perform the shift left operation and decrementing the exponents. Okay, so to overcome this underflow problem in subtraction operation, so we are choosing the shift left operation with decrementing the exponents. Okay, so what is shift left operations? Zeros are added to the right side position and all the bits are shifted one position to the left side. Okay, and decrementing the exponents also. So this is our original information now. So zeros will be added where? So zeros will be added on right position. Okay, so that means here right position means where we are adding here. Okay, after this we are adding the right side bit. So here shift left is nothing but we are adding zeros on the right side position and each bit will be shifted to the left side. This one will be shifted here and this one will be shifted here and this 0 will be shifted here. So then we are getting the 0.110. So automatically here MSB bit will be lost. So then the mantissa, that means here radix will be, what happened? Decrementing. We are one bit is lost now. So then we are getting the power as 10 power 2. Okay, here we are adding the 0. Okay, 0 will be added and each bit will be shifted to the right position. But here the 0 bit will be added on the right side position and each bit will be shifted to the left side. Automatically this bit will be removed. So then now observe the result. Here in the MSB bit of the result will be consist of 0, but in this MSB bit of the result will be consist of 1. So in this way we can overcome the underflow problem. Okay, so we can perform the addition and subtraction like this. Okay, so and last one is, what is the last one? This is the third step. And what is the last step, ma? Last step is nothing but normalize the result. So how can we normalize that result? That is nothing but already we have seen if there is any overflow and underflow will be there. Okay, so we can avoid that overflows with the help of shift right operation with incrementing the exponent, and if any underflow will be there in subtraction, that will be overcome that problem with the shift left operation with decrementing the exponents, right? So this is the normalized procedure. So directly in third step we are performing only addition and subtraction. So after that you can keep it heading as normalized result. Then you may raise these two cases in fourth steps. In that case, if the two cases are raised, so then you can go with these two operations, shift right operation and shift left operation. So this is the total concept of floating point operations of the addition and subtraction. Okay, so in that you may have multiplication and division also there, so that will not much important. Okay, so after completing the syllabus then we'll go with that also. Okay, so first you can concentrate on this addition and subtraction operation. So and in that you may have a flowchart part also, that will be discussed in next class. Okay.